If you just watched the last video, we took numbers and we put them into the scientific notation. Now we're going to be given a couple of numbers and we're going to have to write them in regular, plain old standard notation, just our normal numbers. So we have here 8.673 times 10 to the negative 10th power. We start out with our number 8673. Now remember, our decimal point lies right there, right now. Now this negative 10 power, that tells us that we're going to be really and truly writing out a number that is so tiny. So which way would our decimal point have to move in order to make a smaller number than what we have now? Well, it would need to move to the left. This is what tells us how many places to move it to the left. So we would have to move it to the left 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 places. Because we don't have anything here to the left, we have to fill in each one of those moves with a 0. So my answer in standard notation, or plain old number form, would be 0.0000000008673. That's how we would change it back. In the next example, we have 2.032. I'm going to go ahead and write that out. Oops, that's not very nice. 2.032. Now we are multiplying this time by a much larger number. So in order to make our number larger, we would have to move to the right. And this is what tells us how many places to move. So we would move to the right 4 places. So that tells us we would go 1, 2, 3, 4. And any missing spaces have to be filled in with a decimal. I'm sorry, not with a decimal, but with a 0. So now our number is 20,320. That is this scientific notation written out in our standard form. Finally, once we have understanding of scientific notation and the exponent rules and all of that, now we can start combining all of that and we can do operations, multiplication and division specifically. When we see this multiplication, isn't it true that multiplication is commutative and associative, so it can be done in any order that you want to? Well, if that's true, then I should be able to rearrange this. I should be able to say 1.2 times 3 times 10 to the negative 3 times 10 to the negative 2. Because, remember, it's commutative and associative. We can do it in any order. Now we can multiply our numbers very easily. 1.2 times 3 would be 3.6 times. Here we're multiplying like bases, so we would have to add the exponents. Negative 3 and negative 2 would make that 10 to the negative 5 power. When we're dividing or have a gigantic fraction here, we can really do the same exact thing. We can look at our numbers first. 25 divided by 5 would be 5 times. Here we have dividing like bases again, so we're supposed to subtract the exponents. So that's going to be 10 to the, if you need to do this out to the side, go ahead and do that so you don't get this incorrect. This would be negative 4 minus a negative 9. Remember, we subtract the exponents. So that is truly negative 4 plus 9. So that means we have the 5th power. So when we do that division, we have 5 times 10 to the 5th power.